Assalamualaikum warahmatullahi wabarakatuh. Our topic is about movable hybrid solar and wind turbine. For presenter, the first one is me. My name is Aminah Jela binti Ahmad Tazli. The second one is Muhammad Amizun bin Ali Akbar. And the third one is Muhammad Fendi bin Daud. For abstract, launched in 1888, people tend to build wind turbines that can generate electricity from wind energy. Other than wind, sun has to be everywhere we go. Solar panel or photovoltaic module is a photovoltaic cell assembly installed in an integration system. Photovoltaic cells use sunlight as energy source and produce electricity from direct current. In this study is to build a portable hybrid solar and wind turbine to ease and simplify travelers to obtain solar and wind energy only through wind and sunlight to charge their gadgets. The project is done completely and the turbine works well to charge gadgets. However, the power output is not so high as expected. So traveler do not need to bring power bank because traveler maybe face the problem if the power bank is out of battery. So the first chapter, introduction, it consists of problem statement, objectives, scope of research, and expected result. For introduction, movable wind turbine system is a portable device that generates energy from the source of wind. To generate the energy, it will convert from kinetic energy to electrical energy. The simple wind turbine has three main parts, that is, blade, shaft, and generator. Instead of using typical power bank to charge gadgets whenever they want, they also can use this movable wind turbine to charge their gadgets. Other than the turbine itself, this movable wind turbine also has solar panel that can be used in charging their gadgets. So the solution is using wind turbine because the trains run at least for 20 hours a day with a minimum speed of 30 km per hour. The wind hitting the windows can be converted into valuable electrical energy and hence charge our cell phone. Whether the turbine is charging for convenience or for emergencies, having the backup of wind energy to charge your devices is reassurance of staying connected in all weather conditions. For problem statement, the first one is small devices such as smartphone and camera always out of battery. And the second one is too many things to bring, also a problem to traveler. For objectives, the first one is to design and fabricate new hybrid wind and solar portable charging device. The second one is to measure the RPM revolutions per minute versus times via the source of wind. And the third one is to measure lux, flux per unit area versus times via the source of solar. And the fourth one is to measure and record the current versus time results. For the scope of research, the first one is using air velocity tester to measure the velocity of wind in Pagu Residential College. By this, we can decide on which blade and how many voltages to be used to the wind turbine. The second one is solar efficiency will be tested by using solar tester to make sure that the actual amount of solar panel that can be fit to the turbine. For expected result, we expect that a movable wind turbine product produced that generates energy from wind that can charge gadgets with solar panel that attach to it, besides a hybrid system that combined two different elements, which are solar and wind, will be produced with the turbine. For Chapter 2, methodology, it consists of guidelines used, resources, systematic review process, flow diagram, and data analytics strategy. For the intro of methodology, methodology is the specific procedures or techniques utilized to recognize, select, handle, and analyze data almost a subject. In this portion, it will depict the database used for efficient handle in resources section, following flow diagram session that is to assist a reader more understanding systematic review process utilized. For guidelines used, the first one is identification, which is we identify through database. The second one is screening, and at the same time we will remove the duplicate journals. So the third step is eligibility, and the last step is included. For resources, the journals are grouped into 4 main sections, which is physical sciences and engineering, life sciences, health sciences, and social sciences and humanities. Google Scholar is a freely accessible web search engine that indexes the full text or metadata of scholarly literature across an array of publishing formats and disciplines. Google Scholar indexes includes most peer-reviewed online academic journals and books, conference papers, theses, and dissertations, preprints, abstract, technical reports, and other scholarly literature, including court opinions and patents. It indexes full-text journal articles, technical reports, preprints, theses, books, and other documents, including selected web pages that are related to the scrolling. The most relevant results for the search keywords will be listed first in order of the author's ranking, the number of references that are linked to it, and their relevance to other scholarly literature, and the ranking of the publication that the journal appears in. For systematic review process, the first is identification. So the Scopus, Web of Science, Science Direct, and Scholar Group. So for Scopus, Web of Science, Science Direct, and Google Scholar, we mostly use the same keywords, which is hybrid, movable, wind turbine, wind energy, solar energy, and others. So we proceed with the second phase, which is screening. So for literature type, we use index journal for eligibility, and for exclusion, non-index journals, systematic review journals, chapter in books, conference proceeding. So for language criterion, the eligibility is English and Bahasa, and the exclusion is non-English, excluding Bahasa. So for timeline criterion, the eligibility is between 2001 and 2019. So the exclusion is less than 2001. So for indexes criterion, the eligibility is Mendeley Citation Index, and the exclusion is Mendeley Citation Index expanded. For the third phase, eligibility, in this last phase for the systematic review process, that the chosen articles will be surveyed, and any articles that are not suitable with the criteria will be prohibited before the articles and journals are ready for analysis. We have 78 articles and journals before this phase, and after screening carefully, have some of articles that are unrelated topic and meta-analysis that need to be removed. So for flow diagram, the first one is identification. At first, we have about 115 journals, and after we screen, we have about 78 journals. And for eligibility, we have the total journal of 53, and for included, at the last step, we'll have 35 journals that related to our topic. So for data analytics strategy, quantitative method is the chosen method for the data analysis. The objective of quantitative method is to create and utilize mathematical models, hypotheses, and theories that related to the phenomena. It produces information as it were on the specific cases considered, and any more general conclusions are as it were theories and can be used to confirm which of such hypotheses are genuine. That's all from me. Thank you.
Assalamualaikum and hi, my name is Muhammad Nizul bin Al-Akbar. I will present about the result for our project. We found the 3 journals are related and acceptable to our project. The first journal is an evaluation of the economic efficiency of the wind and solar hybrid power system by Tian Hogu in 2017. Solar and wind. All the possible number of the capacity are listed from the 100 kilowatt to 50,000 kilowatt with an interval of the 100 kilowatt. If the capacity increase, the output at the current capacity will indicate the degree of the penetration of solar and wind energy into the network. The amount of renewable energy loss is also determined by dividing the unused energy by the total electricity output. There is no need to use both when the penetration target is below 30%. Wind is the most cost effective tool in the Atlantic City when the penetration point is less than 30%. In the San Diego, the most cost effective approach is to use solar even when the penetration level is lower. The second journal is Analysis and Design of the Domestic Solar and Wind Hybrid Energy System for Low Wind Speed by Desic and Badia in 2017. From this journal, mentioned on the sunny day, the solar output is high and the generation of the wind is lower, but not at the night or in cloud. Normally, a solar panel is rated at 12 volt output, but at the panel peak open circuit voltage is about 20 to 21 volt. When connected to the load, the output of the same panel decreased to 70 to 80 volts for the wind turbine system. One day the output of the wind generator is small. This lead of the fuel self-defense system. The analysis of the wind pattern and design for the system of the wind turbine proved to be the most challenging work. Based on the power received from the solar, photovoltaic panel and wind generator, the switching action is provided from the microcontroller to the battery charging. Any domestic user can use the solar wind hybrid system in place where wind speed isn't so good. The third journal is Power Electronic Converter for Wind Turbine System by Blanchard, Lisre and Ma in 2012. Multi-pole permanent magnet synchronous generator with full power back-to-back converter look to become the most adopted generator in the near future due the reduced losses and lower weight if they compared to the internal excited SG and the manufacturing successful part. In the last case, the generator is the annually generator and the rotor current is used to regulate the DC-link voltage. All the wind turbine manufacturers are using a step-up transformer for connecting the generator to the grid. That's all for me. Thank you.
Hello, my name is Muhammad Afandi and I will continue with the discussion. For this chapter, the discussion will be about the apparatus that will be used for our turbine, method to make the turbine, and the function for each apparatus used, and also the design of the turbine. For apparatus used, we will be using solar panel, wind turbine, blade of turbine, and battery bank. Process and method. According to Jadkallah, Mahmud, R. and Abdul Qaid, 2016, hybrid wind or photovoltaic system is constructed from the wind energy conversion system represented by wind turbine based on PMSG and solar energy conversion system represented by photovoltaic panel with a control kit in order to meet the requirement for our project based on our testings of air and solar. We have certain specifications that we must adhere to make the turbine, which are maximum operating wind speed 2.5 mm per second, maximum operating wind speed 5 m per second, minimum speed rotation 150 rpm, and portable. For the testing, time of testing 2 hours. For morning 8 to 10, the result is 2.5 to 3 meter per second. For evening 3 p.m. to 5 p.m. 3 to 4.5 millimeter per second, and night at 8 p.m. to 10 p.m. we get 4 to 5 meter per second. The most effective way of using solar energy is to directly convert the sunlight into electricity, and this is accomplished by photovoltaic cells. When sunlight falls on them, They generate DC electric without involvement of any mechanical system. Energy conversion devices, which are used to convert sunlight to electric by the use of photovoltaic effect, are called solar cells. The turbine has been tested by using laboratory wind turbine. The turbine was constructed from induction motor used as a direct driving part of permanent magnet synchronous generator. Variable frequencies give a limited flexibility of rotation speed to the electrical generator. Driving motor has been assumed as the mechanical side of wind turbine, which was designed based on the following assumption. For small wind power generator system, multiple blade type or Darius type is highly suitable. But the main problem with the system is the that the speed of wind is not constant and very fluctuating. Hence, the electric power generated also fluctuated. For function for each part, first is vertical axis wind turbine, function as the blade. Second, tripod, act as the body, tower of the turbine. Switch toggle, electrical switch that is identified by the presence of handle or lever that make it possible to control the flow of electric current. USB compartment, USB compartment. USB port allow the USB devices to connect to each other with and also supply electric power across the cable to device need it. Solar panel to gather the energy and convert it to electricity to the turbine. For conclusion, after we have settled to fabricate the test and model of our turbine, we found that the turbine functioned well to change gadget by using both solar and wind turbine. However, the turbine will still can be worked to charge gadgets. While we were making for the blade, we found that the blade should be smaller in size, probably 15 centimeter, because when we use 10 centimeter, the speed of blade for the wind energy is not rotated fluently, maybe because the blade is heavy to spin, even though we have included the boost ampere inside the turbine. The problem related to the project. First, the voltage that we achieve is 10 volt, which is lesser. The wind turbine cannot be captured. The wind turbine cannot capture the maximum wind in the area. The solar panel cannot get maximum solar energy from sunlight. The weather in Malaysia always changing. The hybrid device has a problem if it exposed to water. Recommendation for the project. First, needs an efficient setup system. Second, make a waterproof cover. At research area, need to always research by time, days, and month to know the average wind speed and sunlight intensity. Solar panels recommended to be adjustable, designed to be able to capture maximum amount of wind. Recommendation for the future: designing new type of blade, using magnetic bearing to reduce friction, use in open space, and turbine design can be made into the DIY system. That's it from us. Thank you.